Day 2 of Lesson 10, Unit 2, Topic 1. This is the last video of this topic about features of functions. Alright, so last time we did a warm-up, it was arithmetic sequences, which meant it was a linear equation. Today it's going to be geometric sequences, because these are exponential functions. And this one tells us that the first term is 8, and then each number after it, you take the previous number and you multiply it by half. So each number is half of the previous number. So I'm going to put my axes all the way down here. And the reason why I'm going to do that is because the first number is 8. 1, 2, 3, 4, 5, 6, 7, 8. The first number is 8. That's all the way up here. And every number after that, you take the previous number and you multiply it by half. So if this is 8, the next number is going to be 4. 1, 2, 3, 4. The next number is going to be 2, and the next number is going to be 1, and the next number is going to be a half. And it's going to look like a hyperbola that looks like the following. With an asymptote of 0, it'll never hit that 0 line. It goes infinitely in both directions. That's why I put arrows on it. This one over here, that's a recursive formula. And this one over here is the explicit formula. So this one states that it's going to start at 3 and it's going to quadruple each time, which I don't think I'm going to be able to fit much of this graph. I'm going to start as low as I possibly can, but I know I'm pretty much only going to be able to graph 2 different points. 1, 2, 3. 3's right there, and it's going to quadruple each time, which means 3 times 4 is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ooh, it almost fit 12. And it's going to go up really super fast because it's quadrupling each term than the previous. And also has an asymptote of 0 because it never hits the 0 line. All right. Getting into this is a continuation of the last lesson, but it's still looking at key features of the graph. Remember, this is still a cultivating lesson about everything you've done in this entire topic. Determine the domain of the range and the x and y intercepts. So you should notice, well, they give you a table, then this is a discrete function, not a continuous function. The domain in this case will be 0, 1, 2, 3, 4, 5, 6. The range will be 2, negative 3, 0, 2, 4, 6, 12, 20. Okay, so the x-intercept. The x-intercept is when it has a height of nothing. So there's the x-intercept, and there's a y-intercept. And the reason I know that is because the y-intercept has an x of 0. The x-intercept has a y of 0. It's just that easy. Based on the table, identify a minimum value and where is it located. So the minimum value happens to be at 1, negative 3. And the reason I know that is because negative 3 is the lowest the function ever goes. Question number 3, determine the domain. The domain is 1, 2, 3, 4, 5. And the range are these numbers. It's once again a discrete question because it's a table. And the x-intercepts, well, I don't see any x-intercepts here. So there's no x-intercepts, and I also don't see any y-intercepts because there's no zeros on the entire table. Based on the table, identify the minimum value. The minimum value looks like it's 5, 3 because that's the lowest it possibly goes for the range. Describe the key features of this situation. The amount of daylight depending upon the time of the year. So that's going to have an increasing interval from December 21st until, what is the other solstice? Okay, so I mean, I can come up with exact dates, but really this is just, make sure that you have the idea of the concepts. So the amount of day is increasing from the middle of winter to the middle of summer, and then it's decreasing from winter back to from summer back to winter again. So you should have noticed by now, I mean, you've been living long enough that you should have noticed that days get longer until summer, and then days start getting shorter again all the way until winter. So that's basically what the increasing and decreasing intervals will be there. It has a maximum of, I still can't remember what month that would be. Is that June? Yeah, I think it is. I think it's June 21st. June 21st, I think, is the longest day of the year, and December 21st is the shortest day of the year. You can check me. I'm pretty sure that's correct. Yep, used to be a science teacher. So that's the increasing, decreasing interval, the maximum and the minimum. And the domain would be all of the months, January, February, March, April, May. It would be all the days, actually. There would be 365 of them. I do not expect you to write that. The range would be, I don't know exactly, but I can just ballpark it. I think in December 21st, I think you have, give or take, about 8 hours of daylight. Maybe less than that. And then during the summer, I think you have more like, I don't know. I'm just ballparking here. Maybe about 15 hours of daylight, something like that. Maybe it's more than that. Maybe I'm probably off on those numbers. I am not positive whatsoever on those numbers. The first term in the sequence is 36. Each consecutive term is exactly half of the previous term. All right, so the domain of this could be all real numbers. because we've talked about multiple times that exponential functions, although hyperbolas curve, they will go left and right infinitely. So you can actually make x whatever you want. The range will have a lowest point of 0. Y would have to be above 0. So in this case, the domain is everything. So we can't really talk too much about that because it could be anything you want. So the maximum, the height it could possibly be is also anything because it's going to go up forever. And the lowest it could possibly be, the minimum could be, well, there really isn't a minimum. The minimum is the asymptote of 0 because it'll never hit 0. All right. Not the greatest of questions. So I'll tell you what, these are all the same things. So Marcus bought a $900 couch on a 6-month interest-free plan. He makes $50 payments on the loan each week. So this is a linear equation. So it's y equals a starting point of $900 minus the $50 he pays per month. If x is the amount of months, or weeks, sorry. He's paying $50 a week. So that's what the equation looks like. So key features of this graph. So it's got a maximum of 900. It's got a minimum of 0 when he's done paying it off. It's got a decreasing interval of 0 to whatever the answer is. How many times? Yeah, I think it's 18 weeks it's going to take for him to pay it off. So 18 weeks would be the domains. We're talking domains, 0 to 18. The lowest would possibly be a 0. And the height would be 900. Okay, I think I already said that. An empty 15-gallon tank is being filled with gasoline at a rate of 2 gallons per minute. All right, so we want it to be 15 gallons, and it's increasing at a rate of 2 gallons per minute. So it's adding 2 gallons per minute, so it's really just 2x. So it's just y equals 2x. And we want to find out how many, well, I guess I should say 15 minus 2x. So if it was full minus the 2 gallons per minute, so after x amount, oh no, that wouldn't work either because that wouldn't tell you how much is in it the entire time. So it's really just y equals 2x, but it stops at 15 gallons. So lowest point it could possibly be is 0. It has nothing to begin with, and then the highest it could possibly be, the maximum would be 15 because that's where it's going to stop. And the domain is going to be 7.5 minutes. So from 0 to 7.5. How do I know that? Because it takes 7.5 times 2 to equal 15. All right, so I'm just going to skip those and go straight to the homework because I know this video is getting long enough. Geometric sequences have a domain that includes all integers. Geometric sequences have a domain that's all integers. I would say incorrect because you're multiplying by anything. Oh, wait. Domain, because if we're talking domain, we're talking about left to right. We're talking about a hyperbola that looks like this. The domain is all real numbers. I was thinking just integers. Oh, I was right to begin with. No, it's not integers. It would be all real numbers. Oh, that's a tricky one. It doesn't just have to be the whole numbers and the opposites, which would be negatives, but it can actually be any number. So technically that is false. Oh, that's such a tricky one. Because of this word right here, it actually can include all real numbers. So it can also include decimal numbers and fractions, not just integers. The range for an exponential function includes all real numbers. The range, that is also a disarray because this one does not go up and down infinitely. No exponential function will have a range of all real numbers. It'll always have a horizontal asymptote. Doesn't have a vertical asymptote, just a horizontal. So that is also a false. 10. All linear relationships are functions with a domain and range containing all real numbers. Okay, so all linear relationships. Okay, so this linear line would go left and right infinitely and up and down infinitely. So you're starting to think the answer is yes. Now, it's actually not true. This is another tricky one again because this line is a function because it passes the vertical line test. It is a function. There's no place you can draw a vertical line and still hit the graph more than once. And it has a domain left and right infinitely, but its range is not up and down infinitely. So this is also a false, and you need to justify the only way to draw a line not have a domain and a range containing all real numbers is if it's a horizontal. It has to be perfectly horizontal. No other function. Every other linear function will have a domain and range of all real numbers. The only one that doesn't, so that means the answer is false, is a horizontal line. So you would say over here that a horizontal line is a linear function, but it does not have a range of all real numbers. It has a range of just one number. So it's because it's x equals. It could be like x equals 3. And if x equals 3, then no matter what the... Well, did I really just do that? It's actually not x equals 3. It's y equals 3. I'm sorry. It's y equals 3. X equals 3 would make no sense. That wouldn't even be a function. Y equals 3. No matter what the x is, y is always 3. No matter where you go left and right, y would also be 3. All right. 10 minutes. Good. Done. And let me know if you have